Good afternoon, everyone, and welcome to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Bam. All right, guys. So to continue today, let's get started with our warm-up. Our warm-up is 122, and it reads, graph the circle, number one, graph the circle. And they give us x squared plus y squared minus 14x minus 10y plus 10 equals 0. Number two, compute the sum, difference, product, and quotient of x plus 2 and x plus 2. Number three, factor by grouping 3x squared plus 17x plus 10. And number four, graph f of x equals x cubed. Then graph the transformation given by g of x. And g of x given is g of x equals 2 f of x plus 3, close parentheses, minus 2. All right, so copy that. If you want to pause the video right now so you can copy it, and I'll go over those really quick. All right, so it goes. Number one, let me make some space here. Let's see if you guys remember. And once again, you have all these notes. I'm just bringing it back so you guys can do the extra practice. So to graph the circle, we need to first get rid of the constant. So we subtract 10 to each side. We end up with negative 10. And then at this point, we put in parentheses like or like terms, common terms. So x squared goes with the x, so I'm going to write that in parentheses, x squared minus 14x, and I leave an empty space, plus, what else? Y squared, what else? Minus 10y, and leave an empty space. Understand why did you leave an empty space, Mr. Q? Remember that we need to complete the square here. So therefore, what is b? Negative 14, and here negative 14 divided by 2 squared. So negative 14 divided by 2 is negative 7. Negative 7 squared is positive 49. And whatever I do to one side, I do to the other side. Here, what is negative 10 divided by 2? Negative 5. What is negative 5 squared? Positive 25. And once again, whatever I do to one side, I do to the other. So I can rewrite this, and I end up with x squared minus 14x plus 49 plus y squared minus 10y plus 25 equals 2. Let's see. So we got 60. This is 74, but then it says minus 10, so that gives us what? 64. Okay. All right, so then what's the next step? We need to factor this. So square root of the first, square root of the last, sine of the middle, and this is squared, plus square root of the first, square root of the last, sine of the middle, squared, and we're left with 64. And this is our standard form for the circle. Now, some of you, if you forgot, remember we do the square root because we know that this is a perfect square, so that's why we are able to factor like that. So let's graph this. So what do we need? We need a center for our circle, and that is HK. So what is it? 7, 5. And our radius is this squared. So square root of, this square root, so 64, take the square root of that, so that is 8. All right, so if we were to graph that, let's see how that looks. Our center is at 7 of x, 5 of y, 7 of x, 5 of y, which is about right there. And then our radius is 8 units in each direction. So if we're at 5 here and 8 more, we end up somewhere over here at what? 13. If we're at 7 and we need 8 units this way, so that means we are at -1. So there's our other point. And here's at 5 and 8 units down, so that's -3. There it is. And then over here, 7 plus 8, that should be at 15. And our circle kind of looks like a circle. Sorry, guys. Anyways, you guys get the idea, right? Come back, yeah? All right. Let's move on. Number 2. Number 2, find the sum, difference, product, and quotient of those two expressions. Here it goes. So our sum is x plus 2 plus x plus 2. So that is 2x plus 4. Difference, x plus 2 minus x plus 2. So the minus, that means this becomes negative, this becomes negative, so we end up with 0. Product, so we need to multiply x plus 2 times x plus 2, distributive property, and we end up with x squared plus 4x plus 4. And quotient, quotient implies what? Division. That is correct. So we end up with x plus 2 over x plus 2. So what do we see here? A giant 1, so that is 1. Yeah, there you go. Now remember, whenever we're multiplying here goes, this is x squared, x times 2, that's 2x, 2 times x, that's 2x, 2 times 2 is 4. So we have x times x. And here, just a reminder, x times x, the exponent is 1. What do we do to the exponents? We add them, right? And here, if the exponent is 1, exponent is 1, what happens to the exponents? They subtract because it's division. So 1 minus 1 is 0. So x plus 2 to the 0, any number to the 0 is 1. There you go. That's another way of looking at it. All right, let's go to number 3. Factor by grouping. Your favorites. Right. All right, so who noticed that we have a leading coefficient? Yeah, so therefore 3 times 10, that's 30. That's our product. 17 is our sum. So factors of 30 that add up to 17. Yeah, 15 times 2, or 2 times 15. All right, so now we can do this by grouping. So that means I'm going to rewrite the trinomial 3x squared, but instead of writing the middle term, what do I write? These two factors, and I write it as 15x plus 2x. Then I bring down the last term, which is 10. Then remember these? Yeah? Yeah. Plus 10. All right, now we can group the first two terms, the last two terms. GCF for these two is 3x. We're left with x plus 5. Plus GCF for these two is 2, and we're left with x plus 5. So look at this term and look at this term. What's the same? X plus 5. That is correct. And what's left over? 3x plus 2. And these are factors. Yeah, remember those? Good. All right, last but not least, graph f of x equals x cubed. So let me do that. And this is just a review so that you guys can remember about the transformations and what each piece does, and especially since you did that home play over the weekend, right? All right, so here we go. F of x equals x cubed. So in case you forgot, x, f of x I'm going to do just going to do 3 points: negative 1, 0, and 1. Negative 1 cubed is negative 1. 0 cubed is 0, and 1 cubed is 1. So negative 1 is negative 1, so that goes right there. 0, 1, 1. Okay, I'm going to do 2 more points. Negative 2 cubed is negative 8. Negative 2 is negative 8. And 2 cubed is positive 8. So the original looks something like this. You guys remember that? Yeah. All right. So, but now they want us to do what? Times 2. So we add a column here. Times 2 f of x. Alright, so 2 times negative 2, times negative 1 is negative 2, 0, 2, and this is negative 16, and 2, 8, 16. So I'm not going to graph these two, but I'm going to graph these. So 0, 0, there it is. Negative 1, negative 2, negative 1, negative 1, negative 2, and 1, 2. So my f of x, without the shifting yet, there it is. What did it do? It stretched vertically because of this 2. So what are the last things that we need to do? Yeah, shift it. This one tells us to go 3 steps to what? To the left, and 2 steps down. So 3 steps to the left, 1, 2, 3. 2 steps down, 1, 2. So this is here now. Now let me move this red one. This one was at negative 1, negative 2. So I'm going to move it 3 to the left, 1, 2, 3, 2 down, 1, 2. And this one, 1, 2, 3, 1, 2. So, and that's our final one. There it is. Yeah? Pretty good, right? Okay, good. Let's move on. Alright, here we go. Our home plate for tonight is only 12 problems. This is play sheet 16.1. So I have express as a single logarithm and simplify if possible. So you have numbers 1 through 12. Copy those. You can pause the video at this moment so you can do each one at a time, or if you want to copy them and leave space for you to show the work, that's fine. However, once you unpause this, here's your Nearpod code to turn in. Nearpod code is EZXPK. EZXPK. So once again, home plate for tonight is play sheet 16.1, numbers 1 through 12 only. Yeah, only. And all this is a piece of cake, guys. It's too easy. Alright? Alright, here we go. Our objective for today, I can simplify logarithmic functions. So what's our main concept or main idea so far? Yeah, logarithmic functions. So in your Fourier model, what do you write? Logarithmic functions, or log functions. And by now you should be able to fill this out by yourself without looking at your notes. If you don't know the definition, remember, keep reviewing your notes, and then make sure on the Nearpod you take a picture and send me your notes of this. Okay. Alright, also a reminder, when we started with logarithms or logarithmic functions, I started with the definition of logarithm, and each part of the logarithm is as follows. The b is the base, the a is a given number, and the x is the exponent. Now I changed the x in some instances for the variable y, just so that we can, because in some logs they usually gave us log b of x or log of x, so that we use the second variable as a y so that we can solve for y. But what is the main idea of all this? That we are solving for the missing exponent. We're solving for the missing exponent. That is correct. And what did we know? That logarithmic functions are inverse of exponential functions and vice versa. All right. So today we arrive to what we call properties. But before I get to properties, we're going to go over three parts of logs that are known as definitions. So what does that mean? That they are more like given, obvious things that you should remember and realize about logs. And they call them definitions. So copy these, please. Log b, or log with base b, and then we got given number b to the m exponent. Second column, log b with a given number b, and the third column, log b with a given number 1. Copy those. Pause the video if you need to. All right, so let's see what is it that we need to remember. And by the way, these you need to remember. You need to keep in your noodle. If you need an index card to write those down and memorize them, guys, because they're going to come up often. Okay, so let's start with this one. So in order for us to solve for the missing exponent, we need to set this equal to y. So I'm going to write y equals log b, and the given number is b to the m power. Okay, so here, what is our base? Our base is what? B. So that means if I was to rewrite this in exponential form, it would be what? B to what exponent? To the y exponent equals to, what is the given number? B to the m. And now it is obvious that we can solve now for the exponent. So what would be our exponent if we were solving for y? Whatever number is there. For right now, I'm going to write m. Y equals m. So this is something to remember. So what is it that you see? Look at this. That the base is the same as the given number. So once again, what would be a definition that you would have in your noodle? That if the log has the same base as the given number, if the log has the same base as the given number, if the log has the same base as a given number, then the solution, or the missing exponent, is the exponent on the given number. Let me repeat that again. If the base is the same of the given number of the log, there it is, log b is the same as the given number, then the solution, or the missing exponent, is the exponent on the given number. Did we get that? Yeah, there it is. All right, let's go to the second one. What do you guys notice on this one? Well, let's rewrite it as like if we're solving for the exponent. So y equals log base b and the given number b. Or like, Mr. Q, isn't that the same? It's almost exactly the same, but it's just, I want to make sure that it's as obvious as we can put it. All right, so once again, what is our base here? Our base is b, and our exponent is y, and all that equal to, what is the given number? B. Okay, so what exponent, invisible exponent, does it have if it doesn't have an exponent? Yeah, that is correct, a 1. I'm going to do an invisible 1 here. There it is. So that means that my solution, or my missing exponent, is 1. There it is. All right, so what can we conclude, or what would be a definition? If a log has the same base as the given number, and the given number does not have an exponent, what is our solution? 1. That is correct. All right, and last but not least, once again, let's rewrite this. Y equals log b and given number 1. All right, so once again, what's our base here? B. Our exponent is y, and all that equal to 1. So question, didn't we already have a definition for number 1? Yeah. What what let me repeat that again. Any number to what exponent will always give us 1? Any number to what exponent will always give us 1? That is correct. 0. 0. So if I was to rewrite this of the same base, that means this has to be base b. Okay? So b to what exponent gives me 1? 0. That is correct. I bring down the other side. There it is. And now we see that y equals 0. These definitions you need to have in your noodle, guys. You need to remember these because they're going to come up often. And mainly the ones that are going to come up more often are probably the first one, this one, and maybe this one. But most, this one will always be coming up. So make sure you have those in your noodle. Okay? Pause the video, copy that, and then we're going to continue. All right? All right. So let's put them to practice. Example Q. Copy these. Log 3 and given number 3 to the 4th power. Log 2 and the given number 2. And log 10 and given number 1. And basically all I did, guys, is put numbers to what we just did with variables. Okay? So here we go. So what do? We rewrite this. Y equals log 3, given number 3 to the 4th. So what's our base here? 3. Y equals to 3 to the 4th. And what do we find out? That y equals 4. All right, so what did we say in our definition earlier? That if the base is the same as the given number, then the missing exponent is the exponent on the given number. Let's see if that works. Let's see. If the base is the same as the given number, then the missing exponent is the exponent on the given number. There it is, 4. Do you guys see that? Now some of you are like, Mr. Key, so could I have just gone from here to here? Eventually, when we get to more properties where you need to save some time and workspace, yeah. But for right now, when you get to some of these that are simple, I just want to see the work so that you remember the process. But that's the basic definition. All right, let's go to this one. Y equals log 2 of 2. So that means the base is 2, exponent y, and this is 2. So what is the missing exponent here, or the invisible one? 1. So that means this is y equals 1. And according to the definition that we came up with earlier, if the base is the same as the given number and the given number doesn't have an exponent, then the solution is 1. Let's see if that worked. If the base is the same as the given number and the given number doesn't have an exponent, the solution is 1. All right. And last but not least, y equals log 10 and the given number 1. So the base is what? 10 to the exponent of y, and that is equal to 1. So if we need the same base, 10 to the what gives us 1 to the 0. That is correct. So y equals 0. And what is the definition to remember? If the given number is 1, then the missing exponent will always be 0. It doesn't matter what log it is. Once again, if the given number is 1, then doesn't matter what log it is, the answer will always be 0. All right. So now that we got those definitions out of the way, let's get started with properties today. Our first property, copy this down, product property of logarithms. Product property of logarithms. Our first one is log b m n, or log b m times n. Why times? Because it's called the what? The product. Now, let's think back to when we did exponential expressions. Look up, guys. Check this out. Remember when we did x to the third times x to the fifth? I gave you plenty of practice in the warm-up. This was what? X to the 3 plus 5, which is x to the 8th. Remember this? Yeah, so what are we doing to the exponents? We're adding them if they have the same base. And what's happening to the expressions? It's multiplication. So if that's true for that, for those, and we know that when we're talking about logs, we're working with exponents, what do you think is going to happen when we write product property of logarithms now that we have m times n? That's right. This becomes log b of m plus log b of n. Copy that. Now, the presentation usually goes backwards. They usually give us this part, and they want us to do this part to simplify. And we're going to do some right now. Okay? So pause the video if you need more time to copy. If not, write example 1. Example 1 reads, express each expression as a single logarithm and simplify if possible. And they give us log 2, given number 8, plus log 2, 16. Copy that. Once again, if you need to pause it, pause it. And over here on the top right, I left the product property of logarithms so that we can remind ourselves what it is. All right. So writing utensils down, look up to the screen. I'm going to do this one, and you can copy at the end. Writing utensils down. Here he goes. All right, first things first. Do they have the same base? Yes, so I write log 2. And what's the given number? 8 and 16, so I write 8 times 16. Why? Because it's a product property of logarithms. All right, so can I rewrite this? Yes. Log 2, and what is 16 times 8? That's 128. So basically just do 16 times 8. 4, 8, 12. There it is. All right, and do we know how to simplify this? Because it says simplify if possible. Yeah. So I write what? All this equal to what? Y log 2, 128. All right. So what is our base? 2 to the y exponent equal to 128. To solve, we need the same base on both sides. So that means this one has to be divided by the same base, which was what? 2. 128 divided by 2 is 64. 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. So we got 1, 2, 3, 4, 5, 6, 7. So this side is 2 to the 7th. So let me rewrite it again. This is 2 to the y equals 2 to the 7th. And what do we know? Y equals 7. All right. So any questions with the product property of logs? All right, copy that really quick if you want to pause the video at this time. You're like, Mr. Q, this is a piece of cake. I know. I'm telling you, it's just like I said before, it's just like more, they're just adding more steps to the process. That's all it is. All right. All right, let's do one together. Example 1Q. Once you unpause it, here we go. Example 1Q. And it reads again, express each expression as a single logarithm. Simplify if possible. So it says log 3 of 3 plus log 3, 81. So since it's addition, what is it implying? That it's our product property of logarithms. So then we rewrite this. This becomes log 3. Why? Because it has the same base. And then what do we write as given number? 3 times 81. So can we rewrite this? Yes. Log 3. And 3 times 81, that's 243. All right, and how do we solve? We set it equal to y. Log 3, 243. Okay, so what is our base? 3. So that's 3 to the y equals to 243. All right, let's solve. How do we solve? They need to have the same base. What is this, the base that I need to use over here? 3. So that means 243 divided by 3. Let's see. I'm going to start with here. Can 3 fit into 2? No. Into 24? Yes. 8 times. And into 3? 1 time. Okay. Again. 3 into 8, that's 2. I got 2 left over. 3 into 21, that's 7. Okay. 3 into 27 is 9. And 3 into 9 is 3. So this could be rewritten as 1, 2, 3, 4, 5. That's 3 to the 5th. So we rewrite this. This is 3 to the y equals 3 to the 5th. So my solution is y equals 5. And once again, what property are we using? The product property of logarithms. Product property of logarithms. All right. Let's go to pause it or pause it and then copy that, please. And once again, I hope you guys are using your colored pen so like that you guys can see the difference from one to the other in the different pieces. All right. All right, let's go to example 1, super cute. Let's see how you do by yourself. So pause it, and then once you copy it, come back and do this one by yourself. Example 1, super cute. Same instructions, and now they give us log 6 given number 12 plus log 6 given number 18. All right. So pause the video, see if you can do that one by yourself, and then I'll work it out with you. All right, now that you're back, here we go. Do they have the same base? Yes, so we write log 6, and it's 12 times 18. All right, so then let's rewrite this. This is log 6, 12 times 18. Let's see, that's 16. I got 1, 8, plus 1 is 9. 1 times 12 is 12. That's 6. 9, 10, 11. Carry 1 is 2, 216. All right, so we have log 6, 216. Let's solve. What do we do here? Set it equal to y log 6, 216. All right, so what's our base? 6, so we have 6 to the y power equals to 216. All right, so our base is 6, and we divide 216 by 6. Let's see. Can 6 fit into 21 here? Yeah, if it's in there 3 times, that's 18, and we got 3 left over. 6 into 36, that's 6. All right, and this is 6 times 6. So 3 of them, so this is 6 to the 3rd power. So let's rewrite that. 6 to the y equals 6 to the 3rd. So our solution is y to the 3rd power, or y equals 3. Hands if you got that. Bam. Yeah, you should have gotten that by yourself, yeah? All right. Any questions on product property of logarithms? No. And that's pretty much it. That's as simple as we can see it. All right, let's move on to the next property. Quotient property of logarithms. And we are given log b and then m divided by n. Why divided by? Because it's called the quotient property of logarithms. So let me ask you a question. If the previous one was product property of logarithms, and what do? Added, right? So what do you think is going to happen with quotient? That's right, we're going to subtract because it's part of the exponents, right? So log b, m over n becomes log b of m minus log b of n. Copy that. Once again, pause it if you need more time. All right, now that we're back, copy this next one. Let's do this next one together. Example 2. Express each expression as a single logarithm, simplify if possible. And they give us log 2 given number 8 minus log 2, 32. So let's do this one together. So what is it that we know? If you need to pause it once again if you need more time. So I'm going to start with blue. What do you guys notice? Do we have the same base? Yeah, so I write log 2. But now that we have subtraction, what happens to the given number? That's right, we divide. 8 divided by 32. So before we get started at that point, let's see if we can simplify to lowest term. So we got log, oh my goodness. Log 2, 8 and 32. Can we divide top and bottom by 8 to simplify to lowest terms? Let's see. Yes. So this becomes 1/4. All right. So let's solve. How do we do that? By setting it equal to y equals log 2 of 1/4. All right. So what is our base? Our base is 2 to the y equals 1/4. All right. Do we have the same base here? Almost. But can we write 4 as base 2? Yes. This will be written as 1/2 to the what? To the second power. However, this is in the denominator. Where do we need to send it? To the numerator. So this becomes 2 to the -2. So now we rewrite this. 2 to the y equals 2 to the -2. And with that said, y equals -2. All right. How we doing? You're like, piece of cake, right? You know what I'm saying? All right. So copy that, pause it if you need to. And now I'm going to give you to do one by yourself. All right. Example 2Q. And it reads 2Q. 2Q. It reads the same instructions, then it's log 4 given number 128 minus log 4 given number 8. Copy that, pause it, see if you can work that one out by yourself, and then when you come back we'll do you'll see the work for that. Alright, now that you're unpausing your back, first of all, do we have the same base? Yeah, so we write log 4, and then we have 128 divided by what? 8. Why divided? Because it's subtraction, and that's why it's our quotient property of logarithms. Can we simplify this? Yes. Log 4, and then 128 divided by 8. 128 divided by 8. Let's see, 8 subtract 4, 8, 16. All right, so this is 16. All right, and what do we do to solve? Set it equal to y equals log 4, 16. All right, so what is our base? 4 to the y power equals 2, 16. Do we have the same base on each side so we can solve? No. So this has to be base 4, so 16 divided by 4 is 4. Okay, so what's another way of writing this? 4 squared, so we end up with 4 to the y equals 4 squared. That means y equals 2. Woo, let's go. How are we doing? Good? Alright. So, and that's pretty much it, guys. I mean, there's other properties that I'm going to introduce on Thursday, but I'm saying for right now, that's as much as I wanted to get done. So, once again, quick reminder, quotient property, we do what? If it's subtracting, that means we're going to divide. And product property, it's sum, that means we're going to what? Multiply the given numbers, and then we simplify at the end. Okay? Alright guys, so once again, our home plate for today's play sheet 16.1. numbers 1 through 12, or all. And your Nearpod code is EZXPK. And once again, guys, as I keep saying, if you're not moving forward, then you're already behind. Bam, let's go from the corner. Alright, guys, I hope everybody's doing alright. Keep up the good work. And once again, I'll see you guys pretty soon. Love you guys. Peace.